Now that we have learned the theory of gradient boosting and random forest, we're going to do a simple demonstration of it using a brute force approach. So this is not the way you should do it in the real world. This is just being done for demonstration purposes. Now we're going to start off this process by just building a simple decision tree like we've done before. So let's just load in our friend the iris data set. And there is all of our data. Let's build a decision tree real fast. And that's the decision tree here that we've seen all, in all the previous videos. Let's do a very quick prediction. We're going to put this tree into the predict command, and we're going to send it all of our data. Let's do that. And you can see that it has given a prediction. So for example, the very last guy has this prediction here, which means he has a 0% chance of being a Setosa, a 2% chance of being a versicolor, and a 98% chance of being a virginica. We're going to use this command. Let's make it a data frame first, so we can do some work with it. We are going to use this command, max column P, and it's going to give the maximum column of every single one of the rows. So let's do that real fast. So you can see that it's telling me what column. So all these guys here, the first few guys, column 1 had the highest. Then we had column 2 for these guys and column 3 for these guys. So you can see that's 1, 2s, and 3s. And then this command here, names of P, is going to give me a vector of these 3 guys, Setosa, versicolor, and virginica. So if I put the 2 guys together and put it into variable R, then that's what we get. We get the names, we get my predictions for all of the flowers. And then if I do this, I think I might have to make this guy a data frame. Let me see. Let's find out. Nope, I didn't have to. Okay, so I've just appended this guy on here, and now I'm going to create one more variable. I'm going to see if this is an error or not. Actually, I don't think okay, I took a little brief fix of code. If you notice, it suddenly changed. Okay, so let's create another guy here that says, is it correct or not? So is the species and the prediction, are they going to be the same? And if I do this, it's going to have a true or false. So if it's a true, it means I've made a mistake, and a false means that I didn't make a mistake. Let's append that to the data frame. And if I were to say, so if you look at all this stuff here, we have all of my data. This is what I want it to be. This is what I predicted. And this is whether or not there was an error. So I made a mistake right here, for example. Okay, so let's just take a quick subset of all my mistakes. And if I do DFX here, you can see these are the ones I didn't get correct. Okay, so that is our decision tree here. Now let's do the same thing with a random forest. And we're going to see how do you do the same thing with a random forest? And we're going to do this with a brute force approach. Do not do this. Do not use this in a real world situation. There's an easier way. We'll talk about it later. I just want you to understand the technique. So let's go over here. Let's open up our R, and now we're going to load in all the things we need. But now we're going to do something a little different. We're going to copy our data frame into another data frame. So if I do head DFN, there it is. So I've done that, but now I'm going to have to get rid of the target. We don't want the species for this. So now if I do head of DFN, I don't have a target. I only got the input variables. Why am I doing that? You'll see. This command, names, is going to give me the names of these variables. Sepal length, sepal width, petal length, petal width. And now I'm going to put those into the variable vars. So if I type vars, that's got all those guys in it. Now, an interesting thing here is if I type in the command sample, and I say sample vars and 2, it's going to give me a random, it's going to randomly go into this list and pull 2 of them out. In this case, sepal length and petal length. If I do it again, now I get sepal length and sepal width. If I do it again, I get sepal length and petal length. So you see, every time I do this, I'm going to get different ones. So we're going to choose, because remember, random forests don't use all the variables. They only use some of the variables. So I'm going to just decide, since I got 4 variables, I'm only going to use 2 of them. Now remember that the decision tree also is a normal sized decision tree. So we're going to say you can go as deep as you want. Go 10 levels deep if you want. It won't go that deep because this is a really simple problem, but that's what we're going to do. So now the first thing we want to do is we're going to build decision tree 1. So we're going to sample our vars, and we're going to take 2 records here. Size is set to 2. So if I type S, you can see I've got petal length and sepal width. Okay. Now I have to add the target back onto that because we have to have something to predict. So I've got petal length, sepal width, and species. Let's build. Oh, now, and also remember, we don't use all of the records. We only use some of the records. We have 150 to work with. We're going to take a random sample of that. So here's my random sample. Now you can see that DF, the dimension of DF, I have 150 records and I've got 5 columns. If I look at the one I'm going to use for my decision tree, I've only got 72 records and 3 columns. So I've got a smaller data to work with. So let's build our decision tree and plot it. And something went wrong. I know it went wrong. I didn't run this code. Let's try that one more time. There it is. So you can see petal length, petal length. It didn't even use the sepal width for this. And he did a real nice job. Setosa, Versicolor, and Virginica. So he did a nice job with this. Virginica didn't do so well. Okay, fine. Now let's go build another decision tree. Let's take another sample. And this time we're going to use the sepal length and the petal width. So the time before we did petal length and sepal width, now we got the other way around. And let's see how many records we got this time. Last time we had 72, now we got 62. Let's build a tree, see what we get. Now we have petal width, petal width. Okay, what else? Let's do a few more of these things. So we got, this is decision tree 3. And he used petal length there. Doesn't seem like you'd like to use the sepals for anything. Let's try this guy. Sepal, sepal. Okay, there, he's used them there. And last but not least, number 5. So I have built 5 small trees. Okay, tree 1, tree 2, tree 3, tree 4, tree 5. Now I'm going to make 5 predictions. So I'm going to put tree 1 in here and give him all the data, and I'm going to put the results in P1. Tree 2 goes here, give it all the data, results go into P2. So there we go. I've got them all in there. And now I'm going to add them all up, P1, P2, P3, P4, P5, and divide by 5. And that will be my predictions. So now let's take a quick look. And there you go. Now, in a real world situation, you would never use a random forest or gradient boosting for a problem this easy. It's just not, you shouldn't do that. But this is demonstration purposes only. Let's do the predictions, calculate the error, and let's see what we got. Oh. Okay, I'm back. I had to fix the code again. I've had a little typographical error. So again, we've got our predictions. We put it in there. If we have any mistakes, they go here. Let's make them a data frame, put it into DF. And now here is all of the ones that we made mistakes with, DFX. And you can see we made mistakes 1, 2, 3, 4, 5, 6. We made 6 mistakes. It's not any improvement on the decision tree, but this is just sort of a general idea of how the random forest works. We're going to use cases where it is much better in the next example. But first, let's take a look at gradient boosting now. And of course, I will post this code. So let's go and bring up the gradient boosting code. And now we will. Now again, do not use this technique. There's easier ways to do gradient boosting. But let's just load in our iris data. Now, you remember from the previous lecture that gradient boosting is a very small tree. So we're going to set the maximum depth to 1. You wouldn't, in a real world situation, you might set the maximum depth to maybe 2 or 3. You wouldn't leave it at 1. But you certainly wouldn't have it at 10. So you keep your gradient boosting relatively small. So let's set that. Now we're going to build our first decision tree. And what we'll do is we're going to copy all of our data into data frame 1. And let's look at the dimension of that guy. And you'll notice it's just all the data. Okay, let's build a decision tree. And you'll notice this is it's 1 level deep. We've got all of our setoses correct, but our versicolor and virginica, it's a 50-50 split. He missed all of the virginicas. He only got versicolors. So we made 50 mistakes here. So what do? Well, what we're going to do is we are going to find out every one that we got wrong. So we're going to use that code and we're going to say, okay, dfx, and that's got all 50 of the ones that we got wrong. And you notice these were virginicas and we thought they were versicolors and there was a mistake. So we got 50 of these guys wrong. So what are we going to do? Well, we're going to take this guy from up here and we're going to add all of the ones we got wrong to df1 and we're going to shove it into df2. So let's do that here and let's see what we have. Now remember, originally we had 150 rows. Now we got 200 because we made 50 mistakes. So 50 plus 1 plus 150 is 200. Now you'll notice we're using all of the variables. Gradient boosting uses all the variables. And he keeps adding to the data set. So let's do this again. Let's take this guy and build another tree. And this time we made 52 mistakes. So now these guys are all setosas, these guys are virginicas, made a lot of mistakes. What do? We're going to add them to data frame 3 and build another tree. Now we made 62 mistakes this time. Wow, this isn't good. But this is what we're doing. We just keep making a bunch of really bad trees. And we do 4, and let's do 5. Or let's just do 4 first. Well, heck, we don't need to. Let's just do them all. So you can see we've got lots of these trees, and none of them are really all that good. However, now we're going to make the predictions, and we're going to average them just like we did before. And I just stopped the tape for a second so I could fix the code again. I had a typo. So let's take and just put this guy inside of our data frame. If I do so you can see here that I've taken and made 5 predictions. I averaged them. I made the decisions as to what these guys were. I'm now going to see if I made any mistakes and add that to the list. If I do. So I didn't make any mistakes in the first 6, but let's do them all. So I made a couple of mistakes here in the middle. But you remember I was making, each little tree was making like 50 and 60 mistakes. But when I averaged them all together, look what I get. So let's just see what the final result was. So again, I have 1, 2, 3, 4, 5, 6. I've got 6 mistakes here. Now, again, the decision tree, the random forest, and the gradient boosting all performed about the same. But that's not the purpose of this. The purpose of this demonstration was to show you what's going on. Now, the next lecture, we're going to do this with the insurance data set, and then we're going to do it the easy way.